Hello everyone, welcome to VMS class. In this lesson, we are going to learn about applying the polynomial regression to predict the salaries. And we are going to learn about the basic idea of polynomial regression, the difference between linear and polynomial regression, and what is the meaning of curve fitting, and how can you predict the salary using this polynomial regression, and how to evaluate the model so that you can understand the real world regression flow. Okay, so for this, the very first step is you have to import all the required libraries. As you can see, the Pandas, Matplotlib, NumPy, and from sklearn, we are going to import train underscore test underscore split to split our data sets into train and test parts. And basically, this polynomial regression is an extension for the linear regression. So, what we have to do before applying this linear regression, we need to extract the polynomial features from the data set. Then we are going to apply the linear regression. So, that is the reason here I am going to import the linear regression model and from sklearn.preprocessing importing polynomial features. So basically, before applying this linear regression, we are going to do some kind of pre-processing on the data set. So in that, we are going to extract the polynomial features. Okay. Now, in the evaluation case, we are going to use three kind of metrics. One is mean absolute error, mean square error, and R2 score. Okay. So let's execute this cell. And the second thing is you need to load your data set. Okay, so I have one data set here. So salary we are going to predict. So the features that we have experience in years and the job role and salary. So basically this job role, okay, we don't have much okay requirement in the training process. Just I want to take the experience in years and I want to predict the salary based on the experience years. Okay, so first let us load this data set into the Google Collaboratory. Okay, so here we have the no data set is available here. You can just click on the export, then you can go to the downloads and select the salary underscore poly.csv file. Okay. Now, and this file is only for this session. And now let's execute this cell and see the sample data set. So here, this is my data set, which has totally three columns. One is experience years, job role, and salary. Okay. And out of that, one is a numerical column, another one is a categorical column, another one is a numerical column. In this, experience years and job role are the input features, and salary is the target feature. Now, just display the first five records here. You can see that I am going to display the first five records to get what is the dataset structure. If you want more information, even you can use a df.info method so that you can see what are the column names and how many non-null values are there. What is the D type of the particular column? Okay, and you can notice that there are 200 entries are there. Okay, the sample size is 200 and all are non-null. Means that the data set is clean, so you no need to do kind of null value removals. Okay. And if you want the statistical summary of the data set, you can use df.describe so that you can see the statistical summary of your numerical columns. Okay. So, and if you want, you can also check the missing values. Already we got some idea in the describe. So where we got the statistical information and you can see the minimum and maximum value. And even in the information, I got some basic idea that all are non-null values. Okay. So let us see how many null values are there. You can see that zero in all columns. Okay. Now, So just I want to see some kind of analysis. How many value counts are there in the job role? Okay, there are multiple roles are there like tech lead, senior developer, engineering manager, software developer. So in each category, how many employees are there? Okay, so you can also check the graphical distribution of this job role. So how many employees are there in each category? Okay, so basically this column is not going to help much. Okay, but just I have mentioned in upcoming projects, you need to do some kind of analysis. That is the reason I have mentioned that kind of cell. Okay, now salary distribution. Okay, I want to visualize the salary distribution in the form of a histogram. Okay, I am giving 20 bins here to see what is the range of the salaries in the data set. Okay, so this is the distribution of the salary in the entire data set. Now, I want to do some kind of analysis how the relationship between the experience and salary, how the relationship between the job type and salary. Okay, so mainly I am taking here experience in years and the salary. You can see the scatter plot over here. From this data samples, you can see that this is not basically a linear straight line, right? It's not a straight line. We have a data can be linear, but the curve you can see that you cannot fit a proper straight line on this. So that's why so the linear regression is not going to help much. So to fit this properly, to fit this kind of curves, we are going to use the polynomial regression. And in this example, even I am trying to show the linear regression as well as the polynomial regression. Both I am going to show you for better comparison. Okay, so now let's see the correlation between the experience salary and you can see the correlation, the experience years and salary, it's almost 0.983437. If the value is very close, so it indicates that positive correlation. Okay. So now, so up to this, the exploratory data analysis. Okay. Now coming to the task, I am going to apply the first linear regression. I want to see the evaluation metric values. Okay, first I am going to check evaluation matrix for linear regression, and then after that I am going to try the polynomial regression and I am going to evaluate that model also. Let's see which model is going to best fit on this kind of data set. Okay, the intention behind is just I want to show you this linear regression may not fit the uh, properly for the curve kind of data. So polynomial regression is the best choice for this kind of data. So that's what the comparison I want to do here. Okay. So now separate the input and output variables here. So X, the experience in years is the X and Y is the salary. Okay. Now split the data set into train and test parts. Okay. With the 80% of data is for training and 20% of data is for testing. Okay, so now I'm going to first apply the linear regression. That is a simple linear regression. So linear regression I am calling and I am creating one simple object here. So linear model dot fit, I am going to train the model on this data set. Okay, now let us predict the values for the test data set. Here you can see linear model dot predict x test I am passing test data and I am predicting that values are storing in linear underscore pred. Okay. Now evaluation metrics I am taking mean absolute error, mean squared error, R2 square. Okay. So mean absolute error I am passing what is the actual y test values, what are the linear predictions, y test values I am passing, linear prediction. For every case I am passing the actual values and linear predictions. Okay. Now you see the error. Okay. Mean absolute error can be 18,727. Okay, and you can see the linear regression MSE. So it is also a big value, and R2 score is approximately 0.971. Okay, you can notice that the error rate is very high on this linear regression. Okay, so now you can also visualize this linear regression model between experience in years and salary. Okay, if you plot this with respect to this scatter plot, okay, now you can see this the straight line. Okay, this is the actual data points how our straight line is going. Okay, so compared to this straight line or a linear kind of data, so this data is slightly different. which is having a slight curve in the data set. Okay. So the second thing, I want to now apply the polynomial regression, right? So polynomial regression, first you have to extract the polynomial features. Okay, polynomial features. I am going to take a degree equal to 2, so that I am going to create an object for this here. X poly equal to poly dot fit underscore transform. I am transforming the input values, okay, from the x to the polynomial features. Now I am going to take the train underscore test underscore split on the x underscore poly. So the transformed features. So now the training size is 0.8 and test size is 0.2. So 80% is for training and 20% is for testing. Now here I am calling the linear regression model. Okay, poly model dot fit x poly underscore train. So here we have the data x poly underscore train on this data, and y train is the actual samples. Okay, now let us execute this set. Now the model has trained. Now predict the salary on the x poly test. Okay, so poly model dot predict x poly test I am predicting on this. Now let us compare the values. Okay, if you see the evaluation metrics of this linear regression MAE 18727, but you see this 5874, and the values for the polynomial regression MSE is also less compared to this. And you see the R2 score, it is around 0.97. And now if you see this, the R2 score of polynomial regression is 0.99. So it is far better compared to the linear regression. Okay. So and similarly, I am going to show you the polynomial regression curve, how this model is going to be fit. Okay, so now you can see that the polynomial regression, okay, you cannot see this line, right? So the reason is the blue, and yeah, so I have actually another diagram there, I can show it comparison. Okay, this blue line is on the top of this points. Okay, now you see this even if you want, you can also create a smooth polynomial curve. Okay, now let's execute this cell. Okay, the data can be smoothed here. Yeah, so coming to this, basically compare linear and polynomial regression. So here I am going to show the plot between, okay, the linear regression as well as polynomial regression. Here you can see one, okay, blue straight line is for linear regression, and now you can see the polynomial regression line. Okay, the same kind of line you are going to see, okay, here. Okay, so now you see how the data is going to fit with respect to the polynomial regression. Okay, polynomial regression model is better fit on this kind of data compared to the linear regression. Okay, so normally the polynomial regression, we are going to have the exponential, okay, features. We are going to add, okay, some kind of new features, okay, that is exponential features based on the degree. Okay, that is the reason it is going to fit this kind of data properly. Okay, so coming to the evaluation or prediction on a new data set. Okay, I am taking the experience is 12. Okay, new experience. Okay, then poly dot transform of new experience. Now I am going to predict what is the salary of the particular experience. Now you can see that the predicted salary is around this value. Okay, we are able to predict it, and even I am giving multiple experience values together. Okay, new experiences, I am giving a list of values, and I am going to first transform the features. Okay, like extracting the polynomial features. So then after that, poly model dot predict whatever the extracted features that I am going to pass to the poly model. Okay, then I am going to display the data frame. Okay, what is the experience and what is the predicted salary here for each of the new test data. Okay, so and even I am going to plot compare and actual predicted salary. Okay, for this, now you can notice that, so some are red point and blue points. Blue points are the actual salary, and the red points are the predicted salary. So if you notice this, okay, almost the blue points and red points are very near to together, right? So that indicates that mostly the actual and predicted values are okay, very near. Hence, the model is performing better, right? So that is the basic idea about this polynomial regression. So from this, you can get some insights. Salary growth is not always linear because the straight line model equation we have seen. Okay, sometimes the salary can be non-linear kind of data. Okay, so it can be vary, right? So polynomial regression basically capture the curved kind of patterns. So it performs better for the non-linear kind of data. Okay, the this model is going to predict the salary based on the experience values. Okay, so try to practice these experiments, okay, so that you will get better idea. Okay, so if you like this video, can please subscribe to our channel for getting more updates on computer education. Thank you. I will see you in the next video.